Welcome back, function students. In this lesson, we are going to look at a few basic questions based on these two functions, the linear and the quadratic function. And this comes from a past paper. First question, but before we continue, they've given us fx's formula there at the top. And in the first question, they ask us to write down the coordinates of B and D. And as you can see, B and D will be the x-intercepts. Therefore, it will also be the roots. So we can read it off directly from the formula given there at the top. Therefore, we can say B is -4. And obviously, y is 0 wherever we have an x-intercept. And D is +6 and 0. So that is 7.1. 7.2. Calculate the coordinates of C. Now C is our turning point, and our turning point formula is x is equal to minus b over 2a. Let's go and substitute. But before we can do that, we have to multiply those brackets out so that we can get it into our general form. Okay, so fx is equal to x squared minus 6x plus 4x minus 24. All right, and that leaves us with x squared minus 2x minus 24. Let's just quickly go and check again. We have x times x is x squared, x times -6, -6x, and 4 times x is +4x. 4 times -6, multiplying the brackets out, is -24. There you go. So now we have our a, b, and our c values. Let's quickly go and sub them. Our b is -2 and our c is -24. A will only be 1. So subbing them in our formula, we then have -2 over 2 times 1. And that leaves us with 1 for the x value. Then we just have to go back and sub it into our y value. In our original formula to get our y value. So wherever we have an x, I will now go and sub 1. All right, so f of 1 is equal to 1 squared minus 2 times 1 minus 24, and that is equal to -25. Therefore, C's coordinates will be 1 for the x and -25 for the y. Let's look at the next. 7.3. Write down the range. Now range is all of the y values of f. As you can see, it stops there at the bottom at c, but we've just calculated the value of c, and it will include everything above the value of c. We've calculated c to be -25. Therefore, we can say for 7.3, y is greater or the same as -25. The last question. Calculate the gradient of AE correct to 2 decimal places. Now the gradient of AE, as you can see here, is on the line that's connected to theta. All right, so there is AE, and we have a little theta there. That is our acute angle or our inclined angle. So because we have that angle, it's given theta to be 14.04. We can therefore say that tan 14.04 tan 14.04 is equal to our gradient, because remember tan theta is your gradient. You just go and place that on your calculator. The gradient will then be 1/4 or 0.25. And that's it for this lesson. Hope to see you in the next.